Hello, grade 6 teachers. Let's have a look at some ways that you can connect computer sciences into your living systems unit. We know that the organizing idea for computer sciences all the way from kindergarten through grade 6 has to do with creativity, design, and computational thinking. By grade 6, your students are expected to have covered a lot of learning outcomes related to computational thinking and design. You will definitely be covering some gaps as you have students coming in that haven't had the new curriculum before. The great news about computer sciences is that a lot of the early learning outcomes have to do with following instructions, understanding what they are, interpreting them, and creating them. So, even though your students might not have been specifically taught how these ideas connect into computational thinking and what computers do, they do understand instructions, they know how to follow them, so you can quickly make connections to different sets of instructions that they know how to follow and how that is the same as when we tell a machine to do something. For example, students, you have a certain set of steps that you go through when the bell goes at the end of the day and it's dismissal time. What are those steps? Well, we know what they are. This is an algorithm that I've programmed you with. When we program robots or machines, we're doing exactly the same thing. We're thinking about all of the different steps that we want that machine to carry out, and we're putting them in a logical order in a language that makes sense to the machine so it can follow those steps. When I give you instructions, I give them to you in a language you understand and in order so that you can remember them. Exactly the same thing. So, bridging those gaps, it can be easily done through classroom routines, simple conversations, and just by bringing that computational thinking and coding language into your other subject areas and your daily learnings. The grade 6 computer science curriculum is heavily talking about students examining abstraction and then connecting that specifically to design and coding. And then they also do go into talking about the impacts of technologies, which is definitely a piece you're going to have to explicitly teach as a part of a computer science unit and possibly bring into some other subjects, but in a different way than connecting in the coding side of computational thinking and the computer sciences curriculum. Students will have been taught up before now about computational thinking and what abstraction is. So if they didn't have grade 5 computer science, you are probably going to have to explicitly teach the decomposing, abstraction, pattern recognition, and algorithmic thinking pieces of computational thinking to them as well in order to get to this level of deep understanding about what abstraction is. So there's a lot in the knowledge category talking about abstraction to help you break that down for your students to make sure that they really understand abstraction and are able to identify and apply it not only in science but throughout their other subjects and their daily routines. The knowledge here is also talking some about some of the structures that we use in coding. So we're looking to have students understand about sequences and conditionals and loops. And if they've been doing any computer science in younger grades, they probably understand these. If they've been coding in Scratch or working with any types of small robotics, these are sort of the basic coding language pieces that we first run into. So they may not know what they're called, but there's definitely a chance that they have a frame of reference for it. As we start to talk about creativity, this is all the way through the computer sciences curriculum. We ask students to use creativity a lot, and traditionally, we might think it applies to more artistic type concepts. So we really want to just draw creativity into the sciences and problem solving and critical thinking. We want to find a new way to get to the same place. Look for a different solution to a problem. If something didn't work, can we creatively think of a new way to try this out and make it actually work for us? That is our creativity. It connects into the design thinking process. You can't do good design thinking if you can't be creative. Students struggle with the testing and going back and fixing. If we're talking computer science, that's the debugging piece. If my program doesn't work, I need to be encouraged to go back and figure out what's happened. So working through, the design thinking process, anytime you can, make reference to these different pieces. Hey, students, we just thought up a bunch of ideas for what to do for PE. What stage of the design thinking process did we do? We're brainstorming, right? And we were thinking about ourselves, or were we thinking about classmates when we were coming up with ideas? Maybe we're talking about putting ourselves in each other's shoes, or if we're deciding what we want to, how we're going to do a specific experiment, and we're putting those steps in order, we're defining, and if we're trying those steps out, we're prototyping. So just anytime we can make those connections to this for them will help them understand and see it as something that they're using and can use all of the time. Same with the computational thinking, just connecting to when we're doing these things, using the language, and then trying to apply it as often as we can for the students to make those connections. When we jump into your living systems curriculum specifically and start to look at some of the ways that you can connect in those CS outcomes into these skills and procedures, if we just grab this first one and we're doing some comparison, we're talking about abiotic and biotic. Right away, students should be making connections to some science content from the past or knowledge that they have about things being alive and not alive. And we're going to learn some new vocabulary here. So we are working through computational thinking because we're looking at particular attributes of living and non-living things and what makes something abiotic. Well, it's alive. So we can have that conversation and we can break it down and decide what makes something alive. It breathes, it consumes food, it makes waste, it uses sunlight, and we can determine that and what makes something not alive. And so we're decomposing things down into their parts, and we're looking for patterns that can help us categorize into these two different groupings, and that is all a part of computational thinking. And if we go through and have students do this label, and then we can extend and say, hey, can you write a set of instructions that would help a person who doesn't know what these words mean do this activity? Or could you write a set of instructions that would help a machine label something as abiotic and biotic? And now we're bringing up to that level of algorithm design, really, really honing in on computational thinking and bringing that coding language into this living systems topic as well. If we can now take what we know about these terms and apply it to some new situation, we've designed those algorithms, so we're really preparing a way to design it into any situation. We're looking at pattern abstraction. So this is an opportunity for us to connect right into the skill about identifying abstraction. So having students understand that they are abstracting when they're applying these rules to new situations and having that conversation, covering this CS skill that actually can be quite complicated for your students to understand. So the more often you can bring this up during your other teaching, the better the chances are your students will have a really good solid understanding of what abstraction is and recognize when they are using that skill anytime that they're doing some critical thinking. We can move into comparing different ecosystems and how this is also going to connect into computational thinking. So this is that abstraction piece where we want to talk about how it is that we are abstracting by comparing these ecosystems. And once we start to write some rules, what do we know about a desert ecosystem? Can you come up with a set of rules about what defines a desert ecosystem? Could you tell a machine how to tell if it's looking at a desert ecosystem? And then by doing these things, we're doing abstraction. Students, this activity, we were abstracting because we took this information that we were learning and we understand about ecosystems, and we broke it down into its basic parts and came up with a set of instructions that a human or a machine could follow to define this ecosystem. So those are really direct comparison between that abstraction piece and how it can connect into not just comparing ecosystems, but anytime you're comparing two things based on certain attributes. As we look at examining diversity, and again, we're looking at the different ecosystems and comparing them. So just making connections back to that decomposing. If we're talking about plants, do we care about the animals? Right now, we're looking at plants. We've decomposed abstract down. We're talking about what kinds of plants live in the different kinds of environments. Why do you think these kind of plants live in those kind of environments? Are there any other kind of plants that could be in this picture? So just making those references, having conversations, we're working through computational thinking, and then anytime you can say specifically, oh, students, let's decompose this. What are we looking at right now? And then we can move to the language. Now, how can you abstract? And maybe then, like, they tell you there's another plant that could go in the desert, and this is why that's an abstraction. So making those connections to this living systems content or any other content where we have the ability to break it down and decompose, we're also teaching that computational thinking. This is an example of a project your students could build in Scratch to explain the process of photosynthesis, but also help them use a visual block-based coding language to create an artifact in Scratch. So there would be some relevant design structure. You could have your students create this project completely from scratch just by looking at this exemplar. They could also take the template that I've pre-created and create this exact animation. If they're not familiar with Scratch, that would definitely be the place to start. The Scratch cards have all of the instructions with all of the Scratch blocks. The template has all of the sprites and the backgrounds, but none of the code. So by taking the template and then following the cards, they would be meeting this computer science skill and procedure, and also explaining the process of photosynthesis that they have understood from their living systems. All of the Scratch cards activities that I have for science and just for general learning about Scratch include all of the blocks. It tells step by step. So if we need to create a variable, those instructions are there. Sprites and backdrops can be easily created in Canva. If your students have access to it and are familiar with it, they can definitely use that to create their own custom sprites and build their projects on their own without even needing a template. And they would really show you what they know about those science concepts if they are out looking for the appropriate sprites and backdrops to complete the projects as well. So that's my Scratch advice. I would encourage students that have some experience to create the projects from scratch, in Scratch, rather than using a template, but the template is definitely there to be used as well. Jumping into just a couple last skills and procedures where we're talking about plants and animals relying on each other to meet needs, and then also about the sacred First Nations and Métis relationships to specific plants. We might not see any computer science naturally within these skills and procedures, but when we're trying to teach students about empathy and how to put themselves in someone else's shoes, it doesn't hurt to stretch a little bit and put ourselves into the shoes of the animal, this poor squirrel who's been displaced with his little suitcase, and have a conversation about, well, geez, how would I feel if my home was destroyed? And how if I rely on my house for shelter and my house is gone, what's going to happen when it rains? And if I rely on the trees for food and the trees are gone, what am I going to eat? And then obviously we're definitely empathizing when we're looking at the perspectives of First Nations and Métis cultures and their relationships with plants. So this would be a time when you could specifically talk about, oh, hey kids, we're doing some of the design thinking process right now. What one are we doing? And then making that direct connection to this is empathizing when we're considering someone else's perspective. Another Scratch project that you can have your students take on connected into creating a model or a simulation. This is a great model or simulation of an ecosystem. Again, if your students are already familiar with Scratch, definitely have them choose a type of ecosystem and build that thing right from the ground up. If your students are newer to Scratch or they just need a little bit of scaffolding, this is a little bit more complicated, this game here, where we're keeping track of a couple of different scores and trying to keep our predator alive by consuming some consumers as well as some water. Again, you can have the students follow the slides. Everything is there for them to just build this exact desert game. But if they want to build something different, they always would have that ability. Use Canva to create sprites and backdrops if they have access. Could do it in Google Drawings or however else they know how to grab some graphics and put them into their little Scratch template, and they could build any ecosystem they like. And then also have some fun playing each other's games, giving each other some feedback on those algorithms, and that'll be working in some of those computer science concepts while we're also learning about ecosystems and creating a model. So those are some ways that you can connect computer sciences into your living systems unit. I hope you enjoyed.